Would an example help? The best way to learn how to play sequential games is to solve some games. Suppose that Milko and a potential entrant are engaged in a sequential game. We'll let M represent Milko and PE be the potential entrant. The potential entrant moves first and must choose between enter, or E, and not enter, N. After potential entrant makes its decision, Milko must decide whether to price aggressive, A, or soft, S. And we have the payoffs. For example, if the entrant enters and then Milko goes soft, better yet, if entrant does not enter, then Milko goes soft. Milko gets $50 and the potential entrant gets $5. So the combination of strategy choices determines the payoff to both players. Again, the first number in the cell goes to the row player, Milko, and the second number in the cell goes to the column player, potential entrant. I'm going to answer two questions. What is the natural equilibrium path? And second, if Milko correctly anticipates that natural equilibrium will occur, should it support a proposal for the government to impose a $15 tax that would reduce by $15 all profit by firms in the industry? Let's start by analyzing the Nash equilibrium. We do this by constructing a tree diagram. We're going to start with a node. Who makes the first decision? In this game, PE makes the first decision, and it's got to decide whether to enter or not. At that point, Milko makes a decision. And Milko's got to decide whether to price aggressively or to price softly. At that point, we get the payoffs. This would be the payoff to, let's do dollars for that. Dollars to Milko and dollars to potential entrant. If potential entrant enters and Milko goes aggressive, then Milko will get -5 and the potential entrant will get -5. If potential entrant goes enter and Milko goes soft, they'll both get 10. If potential entrant does not enter and Milko goes aggressive, Milko gets 0 and potential entrant gets 5. And if the potential entrant does not enter, Milko goes soft, Milko will get 50 and potential entrant will get $5. So we constructed our tree diagram. Now we start at the end of the game and work way backwards. Let's do it in blue. What's Milko going to do if it finds itself at that top node? It either get -5 or 10. Well, -5 is worse than 10, so we can eliminate the aggressive branch at that top node. If Milko finds itself at the bottom node, it can either get 0 or 50. Well, we'd rather get 50 than 0, so again we can eliminate the top branch, the aggressive branch. Milko would go soft. Let's draw this diagram again. Let's redraw the tree diagram, having eliminated the inferior branches. We have potential entrant going first. They chose to enter or not. And Milko moved. And now we've eliminated the inferior branches. All that's left at both the top and bottom node are to price soft, in which case we're going to get 10 and 10, or 50 and 0. Well, now potential entrant moves. It's got a choice between $10 and $0. Well, 0 is worse than 10, so we can eliminate that branch. And what we're left is the equilibrium path is for potential entrant to choose enter, and then for Milko to choose soft. And the payoffs to both players would be $10 given that equilibrium path. Now what would happen if the government imposes a $15 tax on all profits for all firms that are in the industry? Well, a potential entrant enters. That means both it and Milko will be in the industry. So both these profits are going to be reduced by $15. It can be minus 20. That'll be minus 20. In similar fashion, if potential entrant enters and Milko goes soft, profit will go from 10 to minus 5. If entrant stays out, its profit don't change. But Milko is still in the industry. It still loses $15 here, and 50 will go down to 35. So now we can draw the draw the tree diagram again. Potential entrant moves first. It chooses whether to enter or not. Then Milko goes. It chooses between aggressive and soft. Aggressive and soft. And again, this is the dollars to Milko, dollar to TE. Enter gives it, is going to give it minus 20, minus 20. Enter soft is going to give it minus 5, minus 5. Not enter aggressive is going to be minus 15 and 5. And then we're going to have 35 and 5. Let's start eliminating branches. If Milko finds itself at the top node, it can get either minus 20 or minus 5. It doesn't get minus 5 is better than minus 20, so we can eliminate the A branch at the top node. If Milko finds itself at the bottom node, it can get either minus 15 or 35. It doesn't want to get minus 15, and given that choice, we again can eliminate the aggressive branch. At that point, potential entrant finds itself choosing between enter. We're looking at PE. You can choose enter, in which case it's now going to get $5, or not enter, in which case you're going to get $5. Well, 5 is better than minus 5, so we can eliminate the enter branch in this case. The equilibrium path now is for the potential entrant not to enter, and for Milko to play soft. The payoffs in that case are 35 and 5. Notice the payoffs for Milko have gone up from, it was $10 in the original equilibrium to 35 in the new equilibrium. By agreeing to pay a $15 tax and have every other firm pay $15 tax, which looks like something that's bad for Milko, it winds up increasing the equilibrium payoff from $10 to $35. Sometimes doing something that appears to hurt you winds up being better for you at the end of the day.